Good day to you all. As always, I told you, my name is Ibrahim Kabir J, a physics teacher, a mathematics teacher, at the same time, a blogger. We've been solving problems on simultaneous linear equation, where we had a lot of examples solved there. But mostly, it was an equation not in fraction or decimal. It was a straight line equation having a whole number as coefficient of the unknown in the equations. But this time around, looking at the first and second equation here, the variable of x is just 1/2, while the coefficient of the variable x is 1/2 there, and the coefficient of the y variable is 1/3, and the equality sign subjected to two whole number 1/2. And second equation, as you're seeing, it is x/3, which the coefficient of the x down here is just 1/3, while the coefficient of y is a whole number, which is a 3, and subjected to 4. So in this case, what somebody will do is just to make the equation linear, not fractional equations. From equation number 1, for us to make the first equation a linear equation here, we have to get the LCM between the x/2 and y/3, which is just a 6. When you put your 6 down there, then now think how many 2 are in 6. There are 3 2's in 6. Therefore, we have 3 times x. That is for here. Then we now subject our plus down. We now see how many 3 are in 6. Then there are 2 3's in 6, which is just 2 times the y. Then this is equals to, now 2 times 2, which is 4, plus 1, making it to be 5/2. What we're gonna do from there is to clear this by saying 3 times x is just 3x, plus 2 times y is nothing but 2y, divided by 6 equals to 5/2. After having this done, we are to cross multiply the two parts of the equation. What we are going to do is just to say 3x plus 2y, everything in bracket, times 2 equals to 6 times 5. What we are going to have here is to remove the bracket. How? By saying 2 times 3x and 2 times 2y. That is 2 times 3x is 6x, plus 2 times 2y is 4y, equals to 6 times 5 is 30. Now this is the corresponding equation derives from equation number 1. This equation has to be converted also to linear type. How? By creating 1 under 3y. What we are going to have now is the LCM between this 3 and 1, which is automatically a 3. Now, how many 3 are in 3? Here is just 1. Therefore, we have 1 times x, plus how many 1's are in 3? There are 3 1's in 3. Therefore, we are going to have 3 times 3y equals to 4. Now, what we are going to have is 1 times x is just x, plus 3 times 3y is 9y equals to 4. But here is divided by 3. Then create 1 under 4 and cross multiply. X plus 9y times 1 is just x plus 9y equals to 3 times 4 is just 12. This is the second equation. These two equations are processed, ready to solve. Follow us and see how we are going to solve the problem. Thank you. Alright, those two equations becomes 6x plus 4y equals to 30, equation 1, and x plus 9y equals to 12, equation number 2. And this can be solved using any type of method, either elimination method or substitution method, to solve for the x and the y in the two equations. So if you really want to use a substitution method, then you can use equation number 1, use equation number 2 or number 1. But I decided to use equation number 2 and make x subject of the formula by saying x equals to 12 minus 9y. This one becomes equation number 3. From there, we are going to use our equation number 1. Wherever we see x, we substitute the x with the value 12 minus 9y. That means we are going to have 6 bracket 12 minus 9y then equals to plus 4y, plus 4y equals to 30. Now we can simplify this using any respective method of solving problems. Now what we're gonna have is 6 times 12. 6 times 12 is just like this. We have 12 here, 1, we have 72. So 6 times 12 will be 72. Now what we're gonna have is 6 times 9y will be 54. 54y. After having the 54 plus 4y equals to 30, automatically our equation becomes an equation with just one single variable, which is y. We are ready to find the y by subtracting these two out. What we have is 72 minus 54y plus 4y is the same thing as minus 50y's equals to 30. Now we are going to collect the like terms and see what we're going to cancel and what we are going to find. What we have is minus 50y's equals to 30 minus 72 as usual. From there then we are going to have something like minus 50y will be equals to 30 minus 72 will be minus 42. After having the minus 42, we now divide both sides by minus 50 everywhere. Minus 50 automatically goes with minus 50. What we're going to have is y equals to minus automatically goes with minus. When you put 2 here, it's going to be 21. When you put 2 here, it's going to be 25. So the answer is 21 over 25. That is the value for the y. If we want to get the value of the x, we are going to use the third equation, which says x equals to 12 minus 9y. From there then we'll substitute y with the value 21 over 25. What we're going to have is just x equals to 12 minus 9 times 21 over 25. From there then we have x to be equals to 12 minus 9 times 21. It's just something like this. 9 times 1 is 9. 9 times 2 is 18. Sorry. So what we have is minus 189 over 25. Then to make this necessary, we are going to put 1 under 12. After putting 1 under 12, we are going to have our x to be equals to, we have 25. 1 into 25 will be 25 times. 25 times 12 will give you some values like this. 25 here is 12, 2 times 5 is 10, carry 1. 2 times 2 is 2 plus is 4 plus the 1 you carry, making 5. 1 times 5 is 5. 1 times 2 is just 2. What we're gonna have is 0. 5 plus 5 is also 10, put it. Then 1 plus the 2 here, making 3. So the answer we're gonna have there is 300. Then minus 25 into 25 will be 189. So automatically our x going to have values like this. It's going to have a value like x equals to 300 minus 189 divided by 25. Automatically, 300 minus 189, making this 10 minus 9, 1, 9 minus 8, 1, 2 minus 1 is just 1. So the value of x will be equals to 111 over 25. So these are the respective values of the unknown, which is x equals to 11, 1 over 25, and y to be equals to 21 over 25. So these are the respective values of x and y in this very equation. It's not long enough, it's not just long. If you follow the process the way it is, there's nothing hard or big inside there. We are to use our algebraic processes of solving problems and solve this equally. There is nothing big and nothing hard. Thank you very much.